Hello guys, in today's video we are going to push a button on a computer in Ireland, send a signal to a server in Taiwan. That signal will then bounce back to an IoT device in Ireland again that will switch on a small LED. A company called REYAX Technology provided me with login info for their IoT cloud solution. Basically, when you're doing this kind of thing, if you want to send a signal, you need something in the middle between your computer and your IoT device. If your IoT device is measuring temperature and humidity in your greenhouse, for example, you need a server to take the information from your IoT device and transmit it to your computer when your computer is on. Or if you wanted to send a signal to your IoT device to switch on a tap to water your flowers, you would also use the server to send the data from the computer to the IoT device. The REYAX solution is called RYC1001 and it is using the MQTT protocol, so it's set up for low data, so you wouldn't be streaming like video, things like that. This is intended for where you might have a lot of little IoT devices dotted around, kind of low power things. You want to send a signal, you measure the temperature every hour from different locations in your greenhouse and you send it back to your main device. It's not something I've tried to do before, so it's going to be a learning experience for me, and hopefully some of the rest of you guys will learn something from it as well. To get started, we need to download and install a program called MQTT.fx, and that program is going to allow us to send signals from our computer to the server, which will then go to our IoT device. The first thing we're going to do is go to the gear icon here. This is where we're going to enter in the information we got from REYAX. So we want to create a new profile. We'll just call it test up here. We want it to be an MQTT broker. The broker address is the IOT.REYAX.com address. The broker port, we'll not worry about that. For client ID, so you want that to be your username, which you got from REYAX. And then we'll just put a few numbers and a 1 to distinguish between different clients. So this is client 1, for another device it could be client 2, and that way they won't interfere with each other if they're both communicating at the one time. So then we go to user credentials and you put it in your username and your password in here, all of which you got from REYAX. Then you hit apply and just close that box. Now that we have our profile set up, we want to connect, and we can see the green symbol here means we are now connected. So we want to subscribe, and we are going to use API command, then your client or your network ID, in my case it's 33, and a hash. And now we just hit subscribe to that, and we can see that we're subscribed here, and we can see the messages. Next we want to be able to publish a command to it. So we go to the publish section, we set the message here to API request, and from the examples I'm just going to copy a command here. So we are going to do this a little bit different. That device ID, you need to change that to the one that you got from REYAX. I want to control an LED. I'm going to put LED here as well, and we're going to change the result to control LED, and in this case we'll say on. So I'm going to copy that because I also want to do one for off. So once we have our code in, we can say add message to clipboard. We're going to call this one on, and now we have a little button here for sending that command. Now the next one I want to do is to send off. We'll do the same, add the message, and this time it's off. So now we have our two commands here to send. If we try one of the buttons now, it should send the on command to the server, and we should be able to see that here. So we can see that one command has been received, and you can see here control LED on. So let's try off. 2 messages received. It's off. So that is what you would hope to see. So far everything's working fine. Next we need to open up our Arduino IDE and install a library called subpub client, and that is going to allow us to communicate between our ESP32 module and the server using the MQTT protocol. So to find the library, all you do is go to the library manager, enter in subpub client in the search menu, and then click install. We need to make a few small edits to the subpub client library to suit the REYAX server. So to do that, the easiest way is to open up an example from the library just through your examples folder, and then if you click the sketch menu on the very top of the Arduino IDE, you can click show in folder, and that opens up where this example sketch is saved. From here you want to go back 2 levels to the pub/sub client top level folder and then open src folder. Then right click on the pub/sub client.h file and open it with whatever text editor you like to use. With that file open, then you want to change the max packet size to 1024, and you want to change the keep alive to 60. And when you've those changes made, you can save this file, close it, close the Arduino IDE and restart the Arduino IDE, just so that you're sure that the changes have taken effect. Now let's take a look at the code that we're going to upload to our ESP32 module. Now this is mostly based on the code that you get on the RYC1001 datasheet, which is on the REYAX website. You can just download that, and it's towards the end of the PDF document, so you can just copy and paste that into your Arduino here. The only difference is that that code was made for a different ESP module. So for the ESP32 we need to use this Wi-Fi library instead of the one that you see in the instructions. So that's the first thing. We connect to the Wi-Fi library. Then we include the pub/sub client library, which we set up a little while ago. Then we have our variables. These are your ID and your password for your Wi-Fi network. Then for the MQTT server itself, these are the values that you got from REYAX, so the server address, the username and the password. Then it asks for the client ID, so we'll put username in here again, and then 3 zeros and 2, so this will be the second device. So change that to the username that you got from REYAX. Then for the topic, we want it to be the same as we did in MQTT FX. We want API/request. So that's your username and the number of the device that you're at currently, and then API request for the topic. And then just to initialize the 2 libraries, you use these 2 commands. So this one is the Wi-Fi library that's connecting to your Wi-Fi network, and this one is the pub/sub client library that's going to communicate with the server. The next piece of code connects to the Wi-Fi network itself. So here's where the Wi-Fi starts, and it tests here if it has actually managed to connect to the network. So while it's trying to connect, so this is saying while the status does not equal connected, that it delays for 500 milliseconds and outputs a dot to the serial terminal, the serial monitor here. So what that'd look like is a row of dots appearing as it loads. So once it's connected, it just outputs a little Wi-Fi connected, and it gives you the IP address of the IoT device. So this connects to the Wi-Fi, and the next one now, this is connecting to the MQTT server. So you can see here, connects with your client ID and your username and password, and then if it is a successful connection, it serial prints that we are connected. If it's not, it prints out that it's failed, and it gives a well, client state, so like an error code. And then it repeats this sequence. So while the client is not connected, it cycles through this while loop. So every 5 seconds it's going to repeat the test until it gets a successful connection. The next piece of our code then is the setup function, or the setup routine. So first thing is to set the serial so that we can see some information on our serial monitor. The next one then calls the setup Wi-Fi, which we seen a second ago. Then it does the MQTT server, that sets it up here, and it sets up the callback routine, which we'll take a look at in a second. And finally just set pin 2 as an output, so that's going to be our LED. Then inside the loop we have if the client is not connected, that exclamation mark means not. So if we're not connected to the server, we go to our reconnect routine, which we seen earlier, and once it's in that routine it should stay there until it gets a connection. So when it leaves that, the next thing is client loop, which I presume is inside the library that we're using, so that's that pub sub client library. So there must be a loop in there that does certain things necessary to communicate with an MQTT server. The subscribe is subscribing to our topic, which we set earlier, so that's our control LED, and it just loops through that every 5 seconds. The final function then is the callback routine, and that was set up back in the setup function we called client.setCallback. And basically whenever we receive a message from the server, this is going to handle that message. So we are going to get the topic, the payload, and the length of the message. The first thing we do is just print to our serial monitor that we've received a message and the topic is the topic. We then want to add this these characters to the end of our payload so that we can convert it to a string. We have another string here which is going to be our LED state, either on or off, and then we search for the word result in our payload. So it's actually message here because we've converted it to this string. So within that string we look for result, and when we find it we extract the substring, which is from the position where we found result. We want to get the characters at between 23 and 25 in addition to the position of the result. So that should be either on or the first 2 characters of off, the OF. So if it's on, we're going to set the digital pin to high, and if it's off, we'll set digital 2 pin low. So down here we just print out some information on the message we received, just says message, then it's going to output the information, the actual message itself. And then the final thing is just it skips a line, then it gives you the length of the message that you've received. So that's all there is to the code for this. You can upload it to your ESP32 module. I use, which one is it? ESP32 rover module, that's usually the one I would use. To test it now, we've uploaded the code to our ESP32 dev module that's on the left here, and on the right is a little LED test board, and we have the yellow LED towards the bottom of the screen wired to the ESP32 module. So it's that yellow LED that we're going to switch on and off. Now that everything's wired up, we can send our signal by pushing the button on the left. In the log on the bottom right hand corner we can see that it has sent the command to the server from the PC. Now we wait for the signal to reach the IoT device, which it has. We can see on the left, and the LED has gone on, so now we can send the off signal. Again we wait for it to go to the server, which I think might be in Taiwan, and come back to our IoT device to once again turn the LED back off again. And there we go, it's gone off again. So basically we've sent the signal most of the way around the world just to turn off and on that little LED.
Lamp. Look at me, I've got goosebumps.
So there you go, we've pretty much managed to send a signal around the world. I found that pretty interesting, hopefully some of you guys did as well. If you're interested in doing something like this yourself, get in touch with REYAX through their website, and they should be able to advise you on the best way to do it. The link to their website will be in the description. But that's all I have for today. I hope you enjoyed it. Thanks very much for watching. Thanks very much for watching, guys. If you liked the video, please hit the like button, and if you don't want to miss out on the next video, click the subscribe button below and get the bell on for notifications. A big thanks to all our patrons, sponsors, and you guys buying the PCBs for your own projects. That all helps to support the channel and keep the content coming. And speaking of content, there should be links on the screen now to a few more videos if you want to keep watching. And if you go to the channel homepage, you'll see that there are plenty of playlists there to check out. But that's all I have for today, so I'll see you in the next video.